Hi, my name is Shannon, and this is my presentation on Broadway shows for the Computational Thinking class at Virginia Tech. To start off, I chose the Broadway Data Set because watching plays and musicals is a very beloved hobby of mine that I enjoy quite a bit, and I was also eager to see some of the results that this data contained. The findings from this data actually benefit a lot of people. These people include spectators, which are a big majority of the people benefiting, directors, actors, lighting technicians, audio technicians, orchestra directors, as well as the orchestra members. This is to find what shows and events the most time, money, and effort should go into throughout the year. Abstraction is the act of taking real-world objects or phenomena and using other terms to represent parts of each. The real-world events at our Broadway shows are represented by an abstraction that consists of a number of properties. These include the date, which are integer types, representing the day, month, or year a show's week ended in. Statistics, which are all integer types, representing the total amount made over the entire week, number of performances during the week, total number of people who attended performances over the week, percentage of the theater that was filled that week, and the maximum amount an engagement can possibly earn over the week. There's also show, which are string types, representing the type of show played, the name of the production, as well as the name of the theater where the show took place. The data structure for this data set is pretty simple. It consists of a dictionary with the keys date, statistics, and show. Under date, there's another dictionary with the keys full, day, month, and year, with full being a string and the rest being integers. Under statistics, there's another dictionary with the keys gross, performances, attendance, capacity, and gross potential, all being integer types. And under show, there's another dictionary with the keys type, name, and theater, all string types. While evaluating this data set, there were a couple limitations that I ran into. I didn't know what the gross prices consisted of, whether they were ticket prices, concessions, souvenirs, etc. I didn't know how exactly gross potential is calculated. Data is only given on a weekly basis in this data set, so it was hard to find long-term trends. And also the names and casts of the productions aren't given in the data. The questions I wanted to find answers to using this data set are the following. What is the frequency of performances monthly? Is there a relationship between gross potential and the attendance/capacity of the theater during the performance? And using the results from these two questions, I wanted to answer the final question. What shows should the most effort, money, and time be put into during the year? The first visual I created shows the total amount of performances categorized into which month they were performed in, with the last two digits of each x-axis value being the numbered month. As you can see, the months of April, May, and June have the highest number of performances, the highest being in May with over 1,750 performances. These months are considered to be in the spring season. There's then a drop going into the summer months and the fall, but then picks back up again in the winter. In December and January, where there are roughly around 1,500 performances The next visual I created shows the relationship between gross potential and attendance. Gross potential is the maximum amount an engagement can possibly earn based on calculations involving ticket prices, seating capacity, and the number of performances. This number is expressed here as a percentage of what could have been achieved. As you can see, as gross potential percentage increases, so does attendance, respectively. To further support my last visual, I created this visual showing the relationship between gross potential and theater capacity. Capacity is the percentage of a theater that is filled with spectators during a performance and is taken out of 100%. There are a few outliers here that are over 100%, which make this visual a little harder to read. But if you look closely, you can see that as gross potential increases, capacity percentage also tends to increase. After evaluating the data in the data set, I found the answers to my questions. I found out that most performances occur in the spring season, specifically the months of April, May, and June. These are when theaters and their employees are the busiest and making most of their money. I also found that typically shows with a higher potential gross will get higher attendance, therefore having a higher theater capacity percentage. This shows that the more money a performance is expected to make, the more people should be expected to attend those performances. Using the three visualizations that I made, I found that time, money, and effort should be put into all shows, with a little higher emphasis on higher potential shows in the spring season. Thank you for watching.